Hello guys and welcome to FreeBirds2 and welcome to 75-day Hard Generative AI Learning channel. This is day 61 and in our last video I will tell you all about the quantization and how it works and how we can represent the high precision values into the low precision values as well by using the mathematical formula as well. Okay, but our some questions remains. The very first question is how to recover the accuracy while doing the quantization as well. So when we convert a value from a high precision to the low precision, the accuracy drop happens. But we need to capture our accuracy, capture our precision of the large language model. So it does generate a very good responses in the quantized format as well. So that thing can be done like this. Okay, so the main challenge in quantization is to maintain the accuracy and not less than the accuracy fall more than 1%. Okay, there are like many machine learning models where the loss in accuracy is significant when quantization is done. So in this case, there are like a couple of techniques that we can use to bring back the accuracy while doing the quantization. Okay, the very first technique is called partial quantization. Second technique is called quantization awareness training, and third is called learning quantization parameters. So these three techniques are used to recover the accuracy while doing the quantization. And if you see this, that when you use to convert the floating point 32 values to the integer formats like int16, int8, int4 and int3, this is how the accuracy got dropped. If you see this, int16 got the accuracy in a very linear fashion in the increasing format. But if you just reduce the bits to 3, the accuracy got dropped drastically. Okay, so you need to take care of this as well. While doing the quantization, you need to use a very accurate bits as well. It should not be less than int8 because the int4 and int1 bits are not stable bits. Okay, so now let's talk about the partial quantization. So in partial quantization, the idea is to quantize only a few layers in the specific machine learning models and leave out the other layers. Okay, so we leave out the layers for which the loss in accuracy is maximum and hard to maintain accuracy using the other techniques was explored. For these layers, FP32 inference is done. One of the example is BERT large language model. Okay, in BERT large language model, there are like some layers which have the int8 quantization, and there are like some layers who still follow the floating 32-bit format as well. So I already did build videos on the LoRa and QLoRa fine tuning as well, and this partial quantization comes first when we load the model in the quantized format, and then we use the LoRa and QLoRa techniques to do the fine tuning. You can watch these videos. I will put all the videos link in my description and in the I button as well. Okay. Now the next thing is quantization aware training. In quantization aware training, the idea is to insert a fake quantization operations within a graph before training and use this while doing the fine tuning. The advantage is that the model is training and weights are getting calculated. The quantization factor plays a role in the optimization function. So when we have this kind of a fake quantization operations, while doing that, our model and our weights are keep getting calculated. So that means our model knows that quantization is about to happen or is already happening as well. And this technique will improve the accuracy of all the model except these kind of models like ResNet XT or Mask or GNMT as well. So this is because fine tuning does not impact the accuracy beyond run to run variations as well. Okay, so you need to be careful about these kind of models, because in these kind of models this quantization aware training does not work. And our next technique is called learning quantization parameters. So while doing the quantization, you need to know what kind of parameters you need to use. Like what kind of bit precision that you want to use. You want to use the 16 or you want to use the 8 as well. Okay, so that are the quantization parameters that you need to learn while doing the multiple experiments as well. Okay. So our next question is how doing calculations in the INT8 or FP32 gives the same result. Okay, because FP32 has a very high precision and the INT8 has a very low precision. Okay, but the results are still same. So calculations performed in the different numerical format typically do not give the same result because of precision and the representation formats. So the calculations which are done in INT8 and FP32, they produce different results. So but the techniques like quantization aim to reduce the gap between these representation results by mapping FP32 values to the lower precision formats. So in a way that minimize the loss in accuracy as well, and it typically involves the technique like scaling, rounding or clipping to fit the values in a narrower range of the target format. So if I just show you here that this is the whole quantization process. The first is our pre-trained network. We check for the calibration, we check for the calibration model and pick up the best calibration models, like we pick up the best quantization format, and then if accuracy is good, then it is all fine. If it is not good, we build a per layer sensitivity profile. We apply many different kind of techniques. If performance is good, then it's okay. If it is not, then we fine tune. We fine tune with the help of LoRa and QQ-LoRa as well, and then we build our whole kind of model as well. Okay, so I hope you guys completely understand that how this quantization keeps in check about the accuracy and how these calculations are same, because when doing the calculations, the values are mapped to the high precision formats. So in that way, these value results are not getting different as well. Okay. So I hope you completely understand. In our next video, I will tell you about the problems with the low precision formats and why we use INT8 only, and many more things about the quantizations as well. So just be with it, and if you want to know more about prompt engineering, generative AI, data science, you can watch my videos on YouTube and also read my blogs on Medium. We'll meet in our next video. Thank you guys. Thank you so much.